Hi. Okay, it's very good. I'm sorry. I always have to check, make sure it's recording. Hey, this is Dr. Viglione again, and I'm going to go into methylation part 2 or methylation, MTHFR, and more. So I'm going to begin sharing the slides. Be sure you've watched the introduction to methylation before you get into this. Some of it I'm going to review, but I'm going to basically get into the nitty-gritty here a little bit more. All right, let me see. Share screen. Talking to myself here. I had it out. There we go. Okay, so this is going to be the folic acid cycle and MTHFR that we're going to go into. Now, in my last video, I showed you the whole methylation cycle. I think this was Dr. Amy Asko that put this together. It's kind of blurry, and I left it that way on purpose because we're going to break it down into just one section of this because it is a very, very complicated subject. And as I make these videos, eventually we'll cover the whole part. But we're going to start here with a simplification of the methylation pathway. This is the simplest diagram I could find. Okay, it starts with folic acid up here at the top. That's a dietary form of folic acid. You can take it in supplements. It's in food. Some of the food, the green leafy vegetables, has it broken down into folate, which is even better, and it can come through our gut. But folic acid uses an enzyme called DHFR, which is dihydrofolate reductase, that actually converts it into tetrahydrofolate. And this is the type of folate that our body needs. It can't use folic acid directly. It has to be converted into tetrahydrofolate, which then becomes 5,10-methylene tetrahydrofolate. Then the gene that we're going to talk about, the MTHFR gene, comes into play here because it converts it into 5-methyl tetrahydrofolate, which is the part of the folate that's actually active, that then uses, you take that and then use methylcobalamin, which is this methyl B12, and that recycles then the tetrahydrofolate. But in doing so, it creates methionine, which is an amino acid that is essential to multiple processes in the body. But then methionine goes to S-adenosylmethionine, then S-adenylyl homocysteine, and then homocysteine. And you'll hear us talk a little bit more about homocysteine. When that accumulates and gets too high, it's actually very inflammatory and has been associated with cardiovascular disease. So optimal levels are about 8 to 10, and that's where you really want to keep it. You don't want this to go too high. This other part on the right is what we call kind of the back pathway, betaine, dimethylglycine. And we'll talk about that in another video. But the essential part right here is we're going to be looking at the MTHFR and its relationship to tetrahydrofolate. Okay, so I'm going to go over again just briefly what are the functions of methylation. Why is this important? It turns genes on and off. It helps us in detoxifying chemicals and toxins, particularly in our liver. It builds neurotransmitters in our brain and in our gut. Serotonin, dopamine, epinephrine, norepinephrine are huge. We can't function without these. Serotonin is, I call, the feel-good hormone. Dopamine is your motivation hormone. Epinephrine, norepinephrine help you with the fight or flight response, regulate cortisol balance. I mean, it's just huge. And this is the pathway that is integral in this process. It also processes hormones, making sure they don't build up in our body and make us more susceptible to cancer. Crucial in building immune cells, and you'll see that, and why people with methylation defects that aren't treated have poor immune systems, making them susceptible to diseases and cancer. DNA and RNA synthesis, the basic of how our bodies are built and how they continue to stay and run. You have to make new cells. It's crucial in producing energy, ATP in the mitochondria. And then myelination is important because that keeps our nervous system healthy. It's a protective covering on our nerves. And without myelination, they don't work very well. Okay, why again is it important? These are just the fraction of the diseases. Methylation is important in over 200 reactions in our body. And there are so many diseases that methylation has its roots in. And in the first video, I kind of went into some of them. But we're seeing just an incredible amount of infertility now, miscarriages, chronic fatigue syndrome, adrenal disorders, adrenal dysfunction, people on the ASD spectrum, ADHD, autism, multiple sclerosis, other demyelinating disorders, neurodegenerative disorders. I mean, the list goes on and on, guys. I mean, it's just huge, and methylation is integral to this. So even if you've never heard of this before, it would behoove you to learn more about it in your quest for a long and healthy life. Okay, so the key that links all of these disorders is methylated B vitamins. Every person that has one of these disorders has a deficiency somewhere in methyl B12 or methyl tetrahydrofolate. Okay, and this again is a slide that I talked about in the first video, but these are all the neuroimmune disorders and how the things that they affect in the body. It's huge. Okay, so genetics. We're going to go into more of the genetics today. We're going to cover a couple of the key genes that are very easy to have tested. And now, just because you have these genes doesn't give you a death sentence, doesn't mean that you're going to get the disease or all these diseases we're talking about. But if you support these pathways and bring your cofactors up to normal levels, actually super normal is what I found I have to do to help people run their bodies effectively, you don't have to be susceptible to these diseases. Just because you were dealt those cards, you don't have to actually get them. And that's what we call epigenetics, where we're able to influence the expression of our genes. And we call it nutrigenomics, where we're using nutrition to affect the expression of our genes in a positive way. Okay, so what links all of this is methylated B vitamins. Okay, now here is the crucial slide. You'll see folic acid over here on the left. And then you see the little MTHFR down here with the arrow that becomes methyl tetrahydrofolate. Why is that important? It's because folic acid is in a water-soluble compartment of our body. It's a water-soluble vitamin. It cannot get into our nervous system and our immune system because they are fat-soluble. That's why when you have a deficiency in the function of MTHFR, you have weaknesses in your immune system and in your nervous system because you're not getting enough of that vitamin in there. Okay, that's the crucial crux of the whole issue, is getting that folic acid to turn into methyl tetrahydrofolate, which then becomes fat soluble, and you can get into these systems. Okay, so the two common genetic deficient or variants that we're going to talk about today are the MTHFR C677T and the A1298C. And it's not really important to memorize what amino acids are substituted in the DNA base. Just know that when you have these gene variants, that your enzyme doesn't function as efficiently as it should. In fact, when it causes low methylfolate, we always say that instead of methyl tetrahydrofolate, that's a mouthful, but we usually say LMF. But when it causes low folate levels, now with one gene defect, you have a 40% reduction in the activity. When you have two gene copies, then it's a 70% reduction. So it's a much more severe form. Now, this is the C677T gene we're talking about here, but the same goes for the other. Two genes is worse than one. And what they call it heterozygous is if you only have one, and homozygous if you have two. Now, this particular gene is usually associated with high homocysteine levels that we talked about early, which is not good for cardiovascular health, and it's very inflammatory. This isn't always the case. If you have another gene called a CBS mutation, you'll actually eliminate the homocysteine more efficiently. And we'll talk about that gene later. But this is important in DNA regulation, and people with this gene have low glutathione levels. Okay, and this isn't a perfect slide. It's one I put together based on some of the literature I read and some of my clinical experience. Now, I see a huge overlap between this gene and the A gene, which we're going to talk about later. So anything you see here could pretty much be on the A gene, except that the cardiovascular risk seems to be pretty much exclusive to the C gene, the peripheral vascular risk, the stroke, the increased clotability, and miscarriages. The top 5 there seem to be unique to this gene. However, the rest of these, I find that they're present in both of them. And if people have a C and an A gene, they're clearly at risk for everything. But this is, I don't know, this is what you find more in the literature, that it's associated with the C gene. The A gene, it's written that there's a weakness, that the weakness in the production of the L-methylfolate is less. That's not really been my clinical experience. I just don't think enough is known about the A gene. So much focus has been on the C gene because of the cardiovascular risk, which obviously causes a lot of deaths, and the miscarriages for people that are having trouble conceiving and maintaining a pregnancy. However, I deal with a lot of people with chronic illness, and invariably they have an A gene or a homozygous A gene. And I believe that it is just as important and as serious. It just may not be as life-threatening immediately as a cardiovascular disease, but certainly having an autoimmune disease and a neurodegenerative disorder over time is horrible too and kills people too. So I think both of these genes are important. We're not going to go on a whole lot in this video about SAMe, probably nothing actually. And then I'll talk a little bit about, this is again the back pathway that I referred to earlier, tetrahydrobiopterin. Low levels of this are not a good thing. Oh, and people with this A gene also have a deficiency in glutathione production. These are then some of the diseases I put on here. One of the ones that I have noticed, I do a lot of hormone work, as I said before, but hypothyroidism, to me, from what I've seen, is linked more to this gene and then the C gene. I have to always watch people, especially if they have a homozygous double mutation. They are at high risk for thyroid malfunction, particularly low thyroid, and that is something I watch yearly with people with this. And I found that there's a whole lot more incidence of autoimmune disease, chronic fatigue, adrenal disorders, and even I see a lot of susceptibility to chronic viruses, yeast overgrowth, just any infectious, chronic infection. I see a lot more with the A gene. Although again, there's a huge overlap. Okay, and this just kind of gives you an incidence. I haven't updated this. It may have changed. But yeah, I think I've heard actually recently that just having one of the C genes is actually up to 60% in the United States. So that's a huge incidence. And that's just of this, the main gene. There are so many more methylation defects that we'll look at later, but that's huge. If 60% of our population has one C gene, this is something people need to know about and need to find out. I believe it should be tested at birth so that you know right away, and that we could probably prevent a lot of autism if people knew what they had when they were born. Okay, so there's three major biochemical or biomedical issues that occur when you have this. So you're going to have a deficiency of 5-methyl tetrahydrofolate and B12. They go hand in hand. With the C gene, I see a much more profound deficiency of B12 and folate. In fact, some people come to me and they're actually in the danger zone. Their B12 is so low. It causes mitochondrial weakness, so that's your energy production. Nitric oxide deficiency, that is keeping your circulation healthy, your heart and brain, multiple organs are dependent on your blood flow. Cell division and recovery, that's how we heal. Poor neurotransmitter activity, there goes your mental illness, depression, just mood swings, all kinds of things go with that, and poor growth factors. The next one that's a big deal is how it affects your immune system. Remember, it has to get into that fat-soluble compartment to make your immune system right. Now, Th1 and Th2, kind of fancy terms for a balance in your immune system. What you really just need to know is Th1 is more pro-inflammatory, Th2 is largely inflammatory, and the body tries to keep those in balance. When you have too much Th2, though, you actually have more allergy symptoms. So the body needs to keep that in balance. And when you have a methylation problem, these get out of balance and are usually weighted to the extreme of more inflammation. This just kind of shows, and it's more complicated because there's things called B and T cells, and they work together. But B cells are what we usually use to fight bacterial infections. T cells are more to fight cancer, viral infections. but they're both hugely important and they work together. And when you're off balance, you have, again, more propensity towards inflammation and allergies. Okay. Then the third area is the neurotransmitters, dopamine and serotonin. There's a lot of people out today that have depression, have ADD, coming in, I can't keep up with my job, I can't focus. And these are because they're not keeping up with their neurotransmitters, dopamine and serotonin. And serotonin, a good deal of it's made in the gut. And when you have a gut that's unhealthy, you can't make good serotonin, so you don't feel good, you can't concentrate, you don't want to do anything. And you get depressed. It's an epidemic out there. Okay, so what happens when you have these genes? When you're born, you're generally okay, although nowadays, if you check the cord blood, we're finding a great deal of heavy metals and toxicity that the infant is born with. So they already have what we call oxidative stress. Sorry, I've been talking too much. So they already have oxidative stress now when they're being born due to all of these other chemicals. In fact, Lyme disease can be transmitted transplacentally. So, but you have to trigger and to get an illness, you have to have an additional oxidative stress trigger, not just your genetics. Again, the cards you're dealt don't determine the outcome. It's the environment and how it affects those genes. So some of the things that cause oxidative stress are vaccines, severe infections, environmental exposure to multiple toxins, trauma, surgery, even chronic stress, emotional stress. Guys, I mean, we drive ourselves into the ground working, and that is chronic stress on our body. Anyway, that goes into what we call the funnel. And then you end up basically in a situation where when the stressor doesn't go away, that the body's in a chronic fight or flight mode, inflammatory mode, and it gets a disease and it can't get well. And this is I owe this slide and the one prior to Dr. Kendall Stewart, who is a methylation expert also. And I like to attend his lectures when he lectures at the A4M. But I love this slide when he kind of calls it bucket theory, where you've got your methylation supply, and then first thing it does is affect your mitochondrial health. The mitochondria, again, run the body. 90% of our energy comes from mitochondria. So fatigue may be the first thing that people experience. But then it affects, when that bucket has enough, it can overflow to the next one, which is growth factors. And that is basically sustaining our body, repairing tissue, growing. Then we go to the immune system, and last of all, dopamine. So if you have a deficiency, you can see how it affects things in kind of a chronological order here. Typically, when I see people, all of those things are affected. It's rarely just fatigue. Usually there's dysfunction everywhere in the body. Okay, so what we want to do to recover. These are the 4 basic areas. We need to control inflammation and eliminate it if possible. We need to support the mitochondria to give energy, because if you don't have good mitochondria, you can't run the reactions in your body. You can't detoxify. You can't do anything that you need to recover. We need to deliver the essential nutrients, and in this case, it's going to be the methylated B vitamins, and we need to support the person while the healing occurs. I just did a video. No, I guess it wasn't on that, but I should do a video on this. But people, when they take a drug and they have an adverse reaction, they say it's a side effect of the drug, and they ask their doctor if they can switch to another drug. When the body heals and has an adverse reaction to a nutritional supplement, it is typically a good sign. It means that the body is eliminating a toxin. It's doing something necessary to heal. Think about when you go to the gym. It takes pain, it takes work to get stronger and to get better. Same thing goes with healing. The body has to go sometimes through some pain. You've heard no pain, no gain to get well. So when you take something and you have an adverse symptom, don't chalk it up to, oh, I can't take this. No, I'd say most of the time you've got to push through. You've got to push through the detoxification or the healing process to end up on the other side and get better. And that's something where you need a practitioner that can help you work through this. So treatment in general will be methyl donors, and I'll go into this in more detail in other videos, but y'all can go to my MTHFR/biohack page, biohack methylation page, and I tell you what I typically do in my practice, but I use a load of methyl B12, sometimes hydroxy B12, methylated folate, CME, those are all methyl donors. I always support the mitochondria. My favorite supplement now for that is an NRF1 activator. Previously, I used CoQ10. I still have to use that sometimes. I still have to use PQQ and other mitochondrial enhancers. It depends on the person. I always try to balance hormones, treat the gut. Got to get rid of that leaky gut, guys. Got to get rid of those food allergies. I look at other nutritional deficiencies, minerals, etc., and support those. Once I get the body working better, then we go into detoxification. We look at what heavy metals that people have been exposed to, and I try to eliminate those. All this happens with dietary changes, exercise, targeted nutritional therapy, and as I've alluded to before, there's a lot of Lyme disease out there. There's chronic yeast, and I use anti-infectives if needed. So this is kind of just a summary of the concept and what we do with MTHFR. It's not a specific, but it'll give you an idea of why this is something that you should, be concerned about. And I recommend that everybody at least get these two genes tested. I am what we call compound heterozygous. That means I got a C gene from one parent and an A gene from the other parent. And I always tell people with this, we have the worst combination because we're literally susceptible to every disease out there. But I'm living proof that you can compound this, reduce your oxidative stress, get your methylation treated, and I plan to live to 125 to 150. Thanks for tuning in, guys.